Alright, boys and girls, welcome to our second video lesson in Chapter 7, our lesson on similar polygons. Here we go. Alright, a couple words you need to know. Similarity, again, means, you guys, I think we've talked about this, it means same shape. This is the symbol right here for similarity. Okay? The second word you need to know is congruence, which means same shape and same size. We've already talked about that word. And of course, you know the symbol for congruent is that right there. Notice it has both. It has both the same shape piece right here, the squiggle, and the equal sign, which means same size. And equality, of course, means things are equal. They are the same size or the same value. Okay? Similar figures, of course, then have the same shape, but they can be of different size. If a shape becomes bigger, we call that a dilation. If a shape becomes smaller, we call that a reduction. If I have similar polygons, that means that all the angles, the corresponding angles, are congruent, just like if they are congruent polygons, and the corresponding sides are in the same ratio. In other words, they are proportional. This triangle right here, these are similar because they're both right angles, which means now this angle would be congruent to this angle, and this angle is congruent to this angle. And notice now that the ratios of their corresponding sides, 3 is to 12, that's the right-hand sides. The bottom sides, those ratios are 4 to 16, and the hypotenuses, or the hypoteni, their ratio is 5 to 20. Notice that all those sides, the corresponding sides, are proportional, and that proportion is 1 to 4, which is we call the scale factor, and we'll talk about that in a couple minutes. So, similar figures, once again, means that the corresponding angles are congruent and the corresponding sides are in the same ratio. We can see right now that these two, I guess they're trapezoids. They look like they're trapezoids. These two trapezoids are similar because their sides are proportional and their angles are congruent. I want you guys to tell me right now, what is the scale factor of this similarity? Very good. The answer is 1 to 2, and that is because if you look at the top sides, we have a ratio of 8 to 16. If you look at the right-hand side, we have a ratio of 12 to 24. If you look at the bottom sides, we have a ratio of 15 to 30. And if you look at the left sides, we have a ratio of 5 to 10. All those ratios can be reduced to 1 to 2. Okay, we just talked about this now. Two polygons are similar, and again, our symbol for similar is that squiggle right here. Okay, if the corresponding angles are congruent and their corresponding sides are proportional, these two triangles, once again, they are similar. They're all their angles, their corresponding angles, like R and W, they are congruent. S and X, they are congruent. T and Y, they are congruent. And notice that now in our sides, the sides are proportional. All the ratios are 1 to 2, so the scale factor here is actually 1 to 2. All right. Why don't you guys spend a quick second here and list all the pairs of congruent angles, and why don't you write a ratio that relates all of their corresponding sides. Go ahead and stop the tape. Okay, you should have found that A corresponds to J, B would correspond to F, G would correspond to C, etc., H to D, and I to E, which means now we could write here pentagon ABCDE is similar to pentagon JFGHI. JFGHI, which means now AB would be proportional to JF, BC would be proportional to FG, CD would be proportional to GH, DE would be proportional to HI, and there is one more, EA would be proportional to IJ. Okay? Are the following polygons similar? Yes or no? This is almost like a game. It's not quite a game. It's like a game. It's not quite a game because it's just yes, no. Well, the answer to this one, folks, is very good. Negatory. The sides are proportional, but notice that the corresponding angles are not equal. These aren't the same shape. One's a rectangle and the other one's just a regular old pear. Okay? Let's continue with this almost a game, not quite a game. Are these two triangles similar? The answer is quick. I'm about to give it away. Yes. And that is because the corresponding angles are congruent. Of course, we're not quite, we'd have to turn the D triangle up so it looks like this, with the right angle down here, and the double angle here, and the single angle here. And also, the sides are proportional. 3 is to 6, as 4 is to 8, as 5 is to 10. What is the scale factor? Very, very good. The scale factor would be 1 to 2, because 3 is to 6 is the same as 1 is to 2. Find RV and UT. Okay, so in order to find RV, we got to find X. Well, I know now that the corresponding sides are going to be proportional. I got to find a side that matches up. It looks like BC right here. BC would correspond to ST, which means now 4 is to 18, as now on the right side 3 would be to X. I can now cross multiply, and I'm going to get 4X is equal to 54, which means X would have to equal, don't tell me, 27 halves or 13.5. Okay, to find Y, I'm going to match up the same proportion. So I got 4 is to 18, and looking at the bottom now, as 5 is to Y plus 2, I'm going to cross multiply. 5 times 18, I'm going to write that up top where I have room. 5 times 18 is 90. That's equal to 4 times Y plus 2, which is 4Y plus 8. I'm going to divide both sides. I'm going to subtract the 8 first, so I get 4Y is equal to 82. And once again, I have a fraction. Y is equal to 20.5, which means my sides are 13.5 and 22.5. If I plug in my values, let's see if... Whoop, new slide, but that's okay. Okay, let's take a look at this one. So when we're trying to solve more problems with proportions, your steps are to identify the corresponding sides, set up the proportion. If you can limit it to one variable, do it. Solve the proportion, and of course, answer the question. Find the missing sides if the two triangles are similar. Okay, we got to find the missing sides. So in other words, we got to find BC right here, and we got to find ED right here. I will give you guys a chance to do this problem for yourselves. Stop the tape. Okay, you should have found that DE, that's this guy right here, DE is 15, and BC was 24/5. If you had 4 4/5, that's also good, or 4.8. Those are all the same answer. Okay, scale factor we've already talked about is the ratio of the corresponding sides of similar figures. Okay, and again, the scale factor can go either way. You just got to make sure you're either going big to small or small to big. So we can see, like in this case right here, 15 and 5, these are the corresponding sides. So the scale factor of the big to little is 3 to 1. And the scale factor of going small to big would be 1 to 3. And notice that no matter which sides I took, it still works. So if I did AC and DF, that would be 6 to 2, which is what they did down here. It's still a scale factor of 3 to 1. Okay? And again, we now can assume that if all the corresponding sides of the similar polygons are proportional, that means that the total perimeters are also proportional in the same proportion. So the perimeter of polygon A compared to the perimeter of polygon B is going to be equal to the same ratio as the corresponding side of A to a corresponding side of B. Okay, so in this problem right here, we have triangle MNP is similar to triangle RST, and we know that the perimeter of RST is equal to 9. Okay, we can just add up the perimeter of MNP and find the perimeter of that one is 13.5, which means now we know that the ratios of their sides is going to be 13.5 to 9, which can be reduced, doing a little bit of math, 3 to 2. Okay, so to find x, y, and z, to find x, I'm going to use my proportional signs. So x is to 3, and notice I'm going small to big, so I need to make sure I do this now. Small to big over here, 2 is to 3, x must equal 2. Okay, now that we have x is 2, let's find y. Y would correspond to 4.5, so y to 4.5 would equal, again, the same proportion. I can do either 2 to 3, because now that I have my sides, or I can go back to the perimeter. It really doesn't matter. Okay, let's go back to the perimeter just to keep it interesting. 9 is to 13.5. I'm going to cross multiply right now. We got some fractions, but that's okay. I'm hoping you can see without doing much math that y is going to equal 3. So now to find z, z would correspond to 6. Now I'm going to actually go the other way. I'm going to go big to small. So 6 is to z as, and let's just use our sides now. Let's use the small sides right here, 3 and 2, as 3 is to 2. I'm hoping you can see without doing much math that z is going to be 4. If I cross multiply, we get that, but z is 4. So it looks like we have sides of 2, 3, and 4 to go with our other triangle of sides 3, 4.5, and 6. Okay, this last problem right here involves the slope of a roof, the roof of a house. Okay, don't forget that slope is just a ratio. It's rise over run. So it says here the slope of the roof is 4 to 13. Well, I have a total rise of 10, so I'm going to have a total run of x, and that would be just this piece, half of the run right here. So we can cross multiply now, and we're going to get 4x is equal to 10 times 13, which is 130, and divide both sides by 4. So x is equal to 130 divided by 4, which is, don't tell me, 165, 32.5. But now the total length of the roof is going to be 2x, so that's actually right back to 65. So there's the total length of my roof. All right, folks, have a great day. We'll see you soon.